on to our lesson for today, grade 8 technology class. And our topic is still based on structures, but we're going to be looking at rotational forces acting on what? Materials. All right, your presenter today, as usual, is Mr. Said Razak. And then we'll be looking at our lesson objectives. All right. By the end of the lesson, we should be able to list forces that act on materials or objects. We should be able to explain the forces acting on materials. We should be able to evaluate and select materials to withstand forces. And we should also be able to evaluate and select materials for what? Reinforcement. All right, now let's look at the introduction. Forces can either be what? Static, into brackets, stationary, or dynamic or moving. Static forces are usually forces caused by the weight of the structure and anything which it is permanently attached to it. Dynamic forces are caused by things such as wind, waves, people, and vehicles. Dynamic forces are usually much greater than static forces and are very difficult to predict. These are the most common reason for structural failure. So when we are looking at forces, you remember back at grade 7, you did types of forces, and then you looked at static, meaning stationary forces, and dynamic, meaning moving forces. All right. So it is the static force does not have a problem on or an impact on structural issues, but mostly is the dynamic forces that tend to what have damage on structures. All right. Now let's go on. An external force is a force placed on the structure from outside by the wind, perhaps, or by someone sitting or standing on it. So what it means is that we also have internal and external forces. All right. Now, internal forces are the forces which the structure must provide within itself to resist the external forces placed upon it. If the external forces are greater than the internal forces, then a structure will collapse. I repeat it again. Internal forces are the forces which the structure must provide within itself to resist the external forces placed upon it. If the external forces are greater than the internal forces, then a structure will collapse. So what it means is that when we are considering the design of a structure, we must make sure to balance the external and the internal forces, so that if the internal forces, if the external forces is greater or outweighs the internal forces, then the building will collapse. So more often than not, you see story buildings being collapsed. Then what it means is that the external force is greater than the internal force. That's why the building is collapsing. All right. Now let's look at forces now acting on within the structures. So we have got forces acting on and forces acting within a what? A structure. All right. External forces or loads cause internal stress to be set up in a structure. Not all forces or loads act in the same way. Forces can bend, forces can pull, forces can press, forces can even twist. Each of these types of force are given special names. So we're saying external forces or loads causes internal stress to be set up in a structure. So we just saw the previous slide that says that we have got internal and external forces. Now what happens is that external forces are forces that gives stress or a problem to internal structure. And at the end of the day, if the building is not well balanced, then you will see a problem. You will see the structure having a problem. Then these forces can be what? Can be either bent, it can be a force that is pulling, a force that is pressing, or a force that is twisting. And all these have got what? Their names. All right, let's continue with So now let's see if a force, we have got a pulling force, a pushing force, a twisting force, we are going to see here. Now tension. So we are looking at a type of force here, now called tension. And what is a tension force? Is a force which tries to pull something apart. A structural member in tension is called a tie. A tie resists tensile stress. So take note. So you see this diagram there. The object is, you see the arrows is trying, is being pulled apart. So that is what a tension force. We have tension force. They can, we can experience tension force in rubber bands, ropes, and even chains. Anything that can be stretched, we have a tension force there. So when the tension force is more than the tensile strength, then the object will what? Break. All right. So we take note. One of the forces that we are looking is what? Tension force. Okay. Now let's look at compression force. What is a compression force? It's a force which tries to squash or push something together. A structural member in a compression is called a what? A strut. A strut or a strut. Okay, a strut. A strut resists compressive stress. Now let's look. You can see this person. You see where these arrows are. It means they are trying to compress or push or squash the object, and that is what compression. So compression is simply a force that is pushed from both ends of an object, as we can see in the diagram. All right, now let's look at another type of force. So we have looked at tension, we have looked at compression, we are now looking at what? Bending. Bending is a word you will have met before. A structure which is subjected to bending is being stretched and squashed at the same time. So you see, so this person is trying to make sure that the middle of this object is bent somehow. All right. Now let's go on. We have got these diagrams here. A bending force, a combination of forces that causes one part of the material to be in compression and another part to be in what? Tension. In this picture, a sponge with lines drawn on it is bent. You can clearly see how the lines at the top are moved closer in compression, and the lines at the bottom is pulled apart, that is tension. So let's look at it. So the first diagram to my left is what? A sponge. Now if you apply the force, so look, if you hold the ends and you try to fold it, you are doing a compression force at the middle, that U shape. And then at the outside, you see what? A tension. So a bending is a kind of force in which you have got a compression, and then a tension force all playing at the same time. Now we can even also look at this diagram. The top of a shelf is in compression. You now use at our various homes, if you have a shelf where you put your books, sometimes if the books are heavy, then you experience this thing. The weight of the books, you see that will make the object sag a bit. That is what? Compression. But you see that the bottom of the cells is in tension because it's being what? Separated. So on top, you are seeing the arrows facing each other. That is, they are being compressed. The surface of the shelf is being compressed. And at the bottom, you see the arrows are what? Being moved in the opposite direction. It's telling you that the shelf is what? In tension. So bending force is a type of force in which you have combination of forces that comes into play or that acts on that what material. All right. Okay, now we have got other forces. We have got what is called torsion forces. Torsion forces is the name given to a turning or a twisting force. So if you take a paper and you try to turn it or twist it, you are actually exhibiting a what? Or demonstration a torsion force. Now let's see this thing. more diagram there. So we have got two diagrams to illustrate that this gentleman is trying to what? Twist. Now, if you have a signpost, mostly some signpost, you have a wind pushing unevenly on a structure can even cause what? A torsion. Now, what are we talking about? If there is a pivot or a lever there so that this signpost can move about. Now, when there is when a wind is blowing, then this one can exhibit a what? A kind of torsion because it will make that object to twist. Or sometimes, even if there is no lever, but the object or the signpost is a bit flexible, the wind can let the wind will act on the signpost and it can do what? Exhibit, or we can have a torsion force. All right. Now we are done. We have just looked at what kinds of forces. We have looked at what? Bending. We have looked at compression. We have looked at torsion. And then we have also looked at what? Torsion forces. So tension, torsion, compression, and bending. Now let's look at reinforcement. You remember yesterday we said reinforcement is when you add something to another object or structure so that you make it strong. Yes. Today we are coming in from another perspective. We have to adapt the materials to withstand forces. What we are simply saying is that there are some materials that you can take and reinforce them. You adapt, you take the material, try to adjust there and there so that when you use it in the structure, it can withstand or it can hold load. So that is why we are looking at what? Adapting materials to withstand forces. All right. When designing and constructing structures, there are various design issues we need to consider. All right. So you cannot just try to design or build a structure without taking into consideration certain things. Okay. So these design issues that we need to consider include what? Structural elements. What are the structural elements? The structural elements are the structure, what the structure will be made of, or what the structure looks like and what it will do. And we are also looking at what? Reinforcing techniques. These are design issues. Reinforcing techniques. Here we are talking about how it will be strengthened. Then we are looking at what? The stability. Another design issues that we need to consider is stability. Here we are looking at how the structure will be more stable. Then we are also looking at what? Visual pollution. Visual pollution here is whether or not the structure will be attractive to the natural environment. And finally, we will also look at what the structure's impact on the environment. Now, listen, to reinforce something is to make it stronger. That is reinforcement. We can be using beams, we can be using struts in strategic places to reinforce what? The structure. Okay, so reinforcement simply means to make something bigger, stronger. But it might not be bigger but stronger. So it can be small, bigger, and so strong. Here, you just adding something or you making it big. Big in the sense that it's strong, to make it stronger. All right. Now let's look at this diagram here. We have got different ways of trying to reinforce. We can reinforce by triangulation. Triangulation. So you can see that this is a kind of a square or a rectangular structure, but you have got a diagonal edit. So here we call it the triangulation. Another kind of reinforcing technique is tubing. Another kind of reinforcing technique is folding. So take note of this. All right. Now let's go on. We are looking at beams. Beams are also reinforcement techniques. Now beams can withstand load because they don't bend. There are different types of beams according to your needs. So we have got angle beam, we have got I beam, we have got tube beam, we have got T beam, we have also got hollow beam or pipe. So as you can see, the IB looks like an eye. Then the angle beam looks like a right angle triangle, but because there is an angle there, the T beam looks like a T, and the tube is a tube beam. All right, so we have got other beams that are pipe or hollow beam. All right, so all these are what? Structural elements. Okay, now let's look at the stress. So we said stress resist compression forces. So here they support other structural elements which have compression forces exerted on them, and they keep parts of a structure apart. So as you can see, so look at the top of the diagram, the bottom one, you have got a stress there so that it will what? Keep this structure apart. Then on top there, you look at the bottom. Look at the bottom. You have got a load on top, and at the bottom, because of the pressure, it tries to keep those two, the vertical and the horizontal components of these objects to be stable. That is the work of what the structural component called stress. All right. Now let's go on. We have got another ones called ties. Ties are opposite of stress. Now let's try to just preview the previous diagram. You could see that there was a diagonal objects at the bottom, but this time around is at the top. So ties are the opposite of what? Stress. They resist tension forces, which means that they can support other elements that have what? Tension forces exerted on them. All right. Now, so we have just looked at structural reinforcement adapting materials to withstand forces or loads when we are dealing with structural design. Now, another component of structural reinforcement can be concrete. Now, concrete is made from what? Small stones and gravel called aggregate. They sharp sand and then what? Cement. Now, the small stones and gravel that called aggregate is the reinforcement, and the cement is the matrix that binds it together. Concrete has a good strength under compression, but it is weak in tension. So take note. So when you are designing your concrete slabs, you must make sure that it's compressed, but not in the form of tension. As you do it and there is tension, then your concrete will be weak. Now, it can be made stronger under tension by adding what? Metal rods, wire mesh, wires, mesh, or cables to the composite. The concrete is cast around the rods. This is called reinforced concrete. Yes. So what it means is that if you want your concrete to be very strong, mostly these story buildings that we see around, they have what? Reinforced the concrete because they want, can you imagine a story building that is 13 or 15 or 20 floors tall? If the concrete is not reinforced or the structural elements are not reinforced, what is going to happen is that the building will collapse and the people will lose their lives. All right. So for those kinds of buildings, what they do is that they reinforce the concrete by adding even metal rods so that the structure of building can withstand environmental hazards. All right. Now let's look at another type of reinforcement. We also have one called fiberglass. This consists of two distinct materials, a fiber of glass, which is called the ceramic, which is the reinforcement, and a polymer called resin, a polymer resin called polyester, which serves as what? A matrix. Now, what it means is that what is fiberglass made of? Fiberglass is made of fiber and polyester resin, or we can simply say it's made of glass and then what? Polyester. So when you mix them together, then that object or material is going to be very strong. The polyester resin polymer alone is brittle and has a low strength. But when fibers of glass are embedded in the polymer, it becomes strong. Did you hear that? Yeah, you remember we spoke about properties of materials yesterday, and we said one property of material is that it's brittle. Now, when we talk about reinforcement in terms of fiberglass, what they do is that they take the polyester, which is brittle, meaning it can easily break, and it has got what low strength alone. But what happens is that if they should add this polymer, which is flexible, when they add it to the other fibers, now at the end of the day, it becomes very strong, it's tough, it's resilient, and it's flexible. And it becomes an ideal material to make both swimming pool lining, car bodies, roofing, and furniture. So you take note. So you take a material, adapt it so that it can withstand more load. And then when you are adapting it, you are trying to reinforce it so that at the end of the day, the structure that you are designing will be very, very strong. Okay. Now we have already spoken about these ones. So you can take these materials and reinforce them by the various kinds of reinforcement techniques. All right. Okay, guys. I've got an activity here for you because I've been talking. It's now your turn. So what I want us to do is to do, we will do question one bit by, question by question. So question one, you will answer. We will discuss through the chat room, and then you will do what? We will go to question two. All right, it's your turn now to start your class activity. All right, guys, let's answer question one. What is a reinforcement technique? and give one example of reinforcement technique? All right, guys, let's go to question two. Let's go to question two. Question two says identify the following. So you have got the diagrams there. So what I want you to do, I'm saying let's go to question two. Question two says identify the following. So you have got the diagrams there. It's from my left is one, the one in the middle is two, and the other one is the third one. So you say one, what type of structural technique is that? Then in that order. All right, let's keep moving, pushing. Are you all right, guys? Let's go to the next topic. I mean the next question. All right. Question three is saying mention three types of forces you know. And why do we use reinforcement materials for buildings? All right. Okay, yeah, keep your answers coming. That's good. All right. Okay, so let's do the corrections now. All right, so these are the corrections. Question one was saying, what is, so let's look at the corrections. So question one was saying, what is a reinforcement technique? To reinforce something is to make it stronger. So it's a technique used to make what? Something stronger. And then it says, give one example. So tubing, triangulation, and folding are all what? Reinforcement techniques. And then, yes, so number two, it says identify the following. Yes, so the number one was triangulation, number two, tubing, and then what? Number three is folding. Okay. All right. And then the question three was saying, mention three types of force you know. Yeah, most of you got them right. Tension, torsion, bending. You even mentioned compression. You even mentioned shear force. That was very good of you guys. You got it right. Now, number four was saying, why do we use reinforcement materials for buildings? Yes. Yeah, we use reinforcement for materials for buildings because we want to make the buildings strong and what? Durable. So that if there is any natural hazard, the building can still withstand. All right. Okay. These are some links that you can go through to get much information. All right. Now, tomorrow or in our next lesson, we'll be talking about what? We'll continue with structures. All right. So, if you have any question, um, let's send them through the chat room so that we can, I will answer them before we call it a day. All right. Did you hear me, guys? I said if you have any question, you can ask, or otherwise, you will keep it and then till we meet tomorrow. Then you will enjoy the rest of your lessons. Okay, then see you guys. Bye.